So, it's going to be the first video of a big multi-part series on integration, and we're going to be looking at a lot of things. So, we're going to look at to give like a course overview. We're going to be doing sort of what integration actually is. That's going to be this video here. We're going to do the basic integration rules. We're going to do definite integrals. We're going to do area under curves, area between curves, kinematics, exponential integration, trig integration, integration by substitution, integration with trig identities, numerical methods such as trapezium rule, um, then usurp, biparts, why they work. We're going to do repeated biparts, liate, partial fractions, linear denominator fractions, repeated fractions, irreducible quadratics, reduction formulas, all of it, man. We trig identities, trig sub, products of trig functions, completing the square, rational functions, hyperbolic functions, the gamma function, the beta function, what a double integral actually is, rectangular regions, geometric intuition, applications, polar coordinates, average values, Jacobians, um, volume in 3D, mass and density, center of mass, cylindrical coordinates, spherical coordinates, Jacobians in 3D, linear integrals, line integrals, sorry, scalar line integrals, vector line integrals, gradient theorem, Green's theorem, Stokes theorem, divergence theorem, flux integrals, complex parameterization, contour integrals, Cauchy's integral theorem. We don't know residue theorem, but we're just going to begin with A-level maths to start off simply. And this video today is going to be about what integration actually is. So we're gonna we're gonna do that. Let's just do integration. What is it? Well, imagine I tell you a car's speed every second of a journey. Could you work out how far it traveled? Or if I gave you the slope of a curve, could you rebuild the original equation? That's what integration helps us do. Most people learn it as a set of formulas, but before the formulas, you need the idea of, what actually is. So integration is a mathematical process that accumulates quantities. So you're adding infinitely many tiny pieces together, and then you're reconstructing the information and measuring the total change. Differentiation, as we did before, breaks things apart and finds rate of change, and integration works in the opposite direction. It builds things back up. So let's start with y equals x squared. Always start with, y equals x squared. And now y prime, as we've learned, is going to be 2x. So suppose I only knew 2x. Could I recover the original function? Yeah, that's what integrating does. Integrating this function, 2x dx, has a specific rule called the power rule. And we will look at that in the next video. But the formula for that is going to be x to the n plus 1 divided by n plus 1. And so in this example, what is our power of x? Well, it's x to the 1. We're going to add 1 to it, which is going to give us x squared. And then we're going to divide by our new power. We had a 2 here. The 2's cancel, and we're going to be left with x squared plus the constant of integration, c. So integration is often called anti-differentiation or an antiderivative because we're reversing differentiation. But there's a little mystery here. Y plus c. This is what so many students ask, and it's called the constant of integration. Let's look at why this exists. Let's suppose we have the function y equals x squared plus 5. How would you differentiate this? Well, you're going to get y prime equals 2x, but we lose the 5. Differentiate another function. Let's say y equals x squared minus 100. Differentiating gives y equals 2x. We have the same answer here, but we have some lost information. The 5 is missing, the minus 100 is missing. So different functions can produce the same derivative, but differentiation destroys constants. So therefore, when reversing x squared plus c, we are trying to come back. We're trying to get this information um, by just adding this constant of integration because we're unsure of what the constant actually was. But integration isn't just reversing differentiation. It also it measures like accumulation, right? So if you have a curve above the x-axis, the region underneath, integration can calculate the area built from infinitely many thin rectangles. So if I was to just draw like some area, you're going to be adding all of these rectangles together, and they're going to get infinitely smaller and smaller and smaller and smaller until you have the shaded region, which is the area under the curve. And that is what integration is doing. So the rectangles get thinner and thinner each time, and there's no formulas yet. It's just, this is what you are doing. If you have an indefinite integral, then there's no boundary conditions. So, for example, if I have what we've done quite a bit now, the integral of x squared dx, it's just going to become third x cubed plus c. And we'll learn, as I said, about the power rule in the next video and how to, get a lot of these. Um, it it's indefinite right now. If we have limits though, we're gonna become a definite integral. And what that means is that we're looking at between a point. So let's say this is the total area under the curve, but I only want to measure, let's say, from here to here. Well, if we added limits now, so let's say between -3 and 3 of this, then that would help to generate an answer, dx, from, yeah, -3 to 3. So if we was to plug these numbers in to our third x cubed, we would do that and we would take them away because that's the limiting difference there, right? So plug your numbers in. You're going to get a third of 27, which is 9. You're also going to get minus, well, 27, 9, minus 9. So our answer is actually 0 here. So limits tell integration where to start and stop accumulating, basically. So that's, the whole kind of idea. Integration keeps track of direction. And so what we got here is with this function, when we get our 0, we've got 3 above and 3 below. So our definite integral makes it 0, but the total area is actually 6. And mathematicians call this the signed area. Sometimes in applications we want total physical area instead. And you know, that's a good distinction to make. And so yeah, tomorrow in the next video, we're gonna be looking at the power rule and constants and sums. And let's do differences. Differences. So yeah, just today was actually understanding what integration actually means, and in the next episode we'll start doing integration properly and learn the first real rules, the power rule. And so to leave with a challenge, if the derivative of a function, so let's say dy by dx equals 6x, then what is the original function? What might it be? Well, if you was able to deduce the power rule, our answer is going to be 3x squared plus c. So that's the intro to integration, and thank you guys for watching. I hope you understand. Bang. Let's go. Let's get on with it.